Welcome to our tutorial on using data mining algorithms. In this video, we will explore various data mining techniques, their applications, and how to implement them using Java. If you're excited to uncover hidden patterns in your data, you've come to the right place. Let's get started. First off, let's define what data mining is. Data mining is the process of discovering patterns and knowledge from large amounts of data. The data can be structured or unstructured, and the techniques can vary widely. They include classification, clustering, regression, association rules, and much more. We will begin our journey with classification techniques. Classification is a supervised learning technique that assigns a label to new instances based on the training data. A popular algorithm for classification is the decision tree. A decision tree uses a tree-like model of decisions to define the classification of data points. Let's look at a simple implementation using the Java library Weka. In the above code, we start by loading an ARFF file with the help of the Weka library. The J48 classifier is a popular implementation of the C4.5 algorithm. After building the classifier, we print out the decision tree. Now that we have an understanding of decision trees, let's move to the next classification technique, naive Bayes. Naive Bayes classifiers are based on Bayes' theorem, assuming independence between the features. In this example, we similarly use the Weka library to implement a naive Bayes classifier. After training the model on the dataset, we output the classifier model, which will provide information on the probabilities of different classes. Next, let's discuss clustering, an unsupervised learning technique that groups data points into clusters based on similarity. One popular clustering algorithm is the k-means algorithm. Here, we specify the number of clusters we want the algorithm to identify using set number clusters. After building the clusterer, we call getAssignments to retrieve the assigned clusters for each instance in our dataset. Now that we have covered classification and clustering, let's shift gears to association rule mining. This technique is used to uncover interesting relationships between variables in large databases. The classic algorithm for association rule mining is the a priori algorithm. In this case, we use the Weka library to set up the a priori algorithm. After training it on our dataset, we print the discovered association rules, which can help businesses identify purchase behaviors. So far, we have explored different algorithms. However, understanding how to evaluate and validate these models is equally important. Let's dive into model evaluation. To evaluate classification models, we often use metrics such as accuracy, precision, recall, and F1 score. Weka provides a convenient way to perform cross-validation. In this example, we are performing a 10-fold cross-validation on our classification model. The evaluation class helps us in assessing the performance of the classifier, providing detailed metrics. Finally, before we close off, it's important to understand the ethical considerations of data mining. Always ensure you have the right permissions to use the data and be transparent about how you process and analyze it. We have reached the end of our deep dive into data mining algorithms. We explored several classification and clustering techniques, along with model evaluation and ethical considerations. We hope you find these techniques useful in your data analysis endeavors. Thank you for watching. If you enjoyed this tutorial or have suggestions for future topics, please leave a like and subscribe to our channel. Happy coding!